Yo, alright folks, Haynes here, and welcome to another video in our CAD series. So today we're going to be diving into an important that might seem pretty simple, might seem pretty mundane, but is actually incredibly important in engineering, CAD, technical drawings, and that is dimensioning standards. Might sound a little dry, but stick with me because understanding how to write and interpret dimensions correctly is gonna be crucial if you want to excel or even be mildly successful in this field. So let's get right into it. All right, so standards. Imagine trying to decode a drawing where everyone just turns in their own thing in terms of dimensions. That'd be pretty chaotic, right? And that is why we have standards. Yep, these are rules that make sure we're all on the same page, literally. So in the United States, we have what we call ANSI standards, which is the American National Standards Institute. Internationally, over in Europe primarily, they use ISO, which is the International Organization for Standardization. We have a few other standards over here, but primarily you're only going to be dealing with ANSI, which a lot of times you're going to see that in American architectural drawings. ISO, a lot of the technical drawings I'll do in ISO standard because it's more universal. The rest of them you probably won't be seeing as much unless you go to certain localities around the world. Now, let's break down what actually goes into dimensions. So first we have the extension lines, and those are these fellas here that line up with the point in question. All right, then we have our dimension lines. These are these little fellas here with arrows pointing towards the outer limit of the dimension. Then we have our arrowheads. Right, there we go. And our dimension text, which is going to be centered in the middle of the dimension so long as there's space for it. There are cases where we will offset them if text is overlapping, but generally speaking, those dimensions are going to be at the center point there. Alrighty, so dimension text is going to be centered both vertically and horizontally, both ways, as you can see there. So our dimensioning methods, we are primarily going to be using our unidirectional method, which is all the text is facing the same way. That is primarily what you're going to be seeing in engineering drawings. And then we have aligned. This is not my personal favorite, but in architectural drawings, you do often see aligned dimensions. It can be easier to read if you're doing things in a massive scale, but primarily in terms of engineering and in terms of our orthographic drawings, you are going to be seeing unidirectional dimensions more often than not. So classifications of dimensions. So dimensions are the things that describe the size of our object or the size of a feature. So here we have this 3 here. That would be a size dimension along with these 1s here. But we also have another kind of dimension that describes where something is in relation to something else. So for example, our 1/2 here, these two 1/2s are telling us that the center point of this circle is a half of a unit. We don't know what units we're in right now, maybe a half a mil, could be a half an inch, but it is a half a unit up from our bottom line, and it is a half a unit to the right of our left edge here. So again, we have size dimensions like the 3, the 1, the 3 is this whole side, the 1 is this whole side, this one is center point to center point, and then we have location dimensions that tell you where something is relative to something else within our drawing. Alrighty, so we have a few different methods of how to dimension something. First one is going to be chain dimensioning, So that is what's represented down here. So with chain dimensioning, we have a series of dimensions that are in line, all butting up one next to another. Same as these 0.5s down here. Oops. And then method 2, we have another form of chain dimensioning, where so we have these two butting up to each other, and then we have this 2.25 that describes the entire length of this bottom line or this edge to this edge. And you don't need to put the third 0.75 there because you could infer it from taking away 1.5 from 2.25. You would get that 0.75 there. So this is a preferred method of dimensioning. It's a lot cleaner. And it does tend to be a lot more accurate, because when you are, the more dimensions you put into something, a lot of times those are going to be rounded off. So this may be 0.749826, or it could be 0.75426972, or what have you, and it could be rounded off. So when you dimension a longer object and dimension it fewer times, you leave less margin for error the more times you repeat yourself. I said that a little bit convoluted, but hopefully that makes sense. So this would be an example of over dimensioning. We don't need this here. We don't need one of these 0.75s. This one should be eliminated. And we don't need one of these 0.5s. That is redundancy. So that is a no-go. Try not to over dimension things. It just clutters up your drawing. All right. We also have baseline dimensions. So baseline dimensions are a series of dimensions where instead of butting up next to each other, as was the case on our last slide, these ones go vertically up or horizontally to the side. They start at the same end point or start point or baseline, and then they all go to different endpoints. This for me is a very clean and potentially more accurate way of dimensioning, because it leaves less margin for error on, as opposed to chaining. Each one could have margin of error, but I like these. So instead of having our 0.75s continue along, we then add the two together, we get our 1.5, and add the 3 together, we get our 2.25, and we'll notice that they are remaining centered vertically and centered horizontally still within our brackets. And same kind of deal over here. All right, but we're going to get into this in part 2 of the video, but that is going to do it for today. Over in part 2, we are going to get into a few other things like dimensioning angles, and dimensioning round objects like arcs, circles, and even splines potentially. But that's going to do it for today's video. Appreciate you watching, and like always, I hope you have a great day.